Hey guys, Miss Kennedy here. I am going to show you how we're going to mark up this periodic table so that when you get this on a test or a CFA, a unit assessment, or just your regular work for the day, you will know how you can brain dump all over it. So we're going to start off here with this little element box. We learned last week the phrase ape man. So we are going to put that on here first. So it's already labeled atomic number. What else does that atomic number stand for? This atomic number also tells me the number of protons. So I'm going to put atomic number equals my protons. I'm going to underline this A, so we know that stands for atomic number. It's equal to the number of protons. It's also equal to the number of electrons. So that's the 8. We also talked about the second part of that, which is man. M stands for mass. So the mass minus my atomic number, and y'all, this is a number sign. Back in the day, we used this as a number sign. I know you like to call it a hashtag. We're calling it a number sign. So atomic number, mass minus atomic number is equal to the number of neutrons. So ape man. And then one of the exit tickets last week asked something along the lines of which element has the greatest mass, and to find that you had to add up the protons plus the neutrons. So I drew an arrow pointing to my mass and I wrote P plus N because that is how we figure out the mass. Remember, those electrons are so tiny that we don't even count them in the mass. All right, we're going to label some things on here. So going horizontally are, oh gosh, this is not very pretty. That's okay. Are my periods. And by the way, y'all, I'm not the best. I don't have the best penmanship. My writing is legible, but it's a little rough. So just hang with me. All right. So these are called periods. They go horizontal. Zoom this in a bit. Maybe. Let's see if I slide this over. All right. So these are my periods. And these periods are also energy levels. So I'm going to put periods equal energy levels. Energy levels. So, for example, period 1, every element in this row, in this period, has 1 energy level. So that's like when we drew our Bohr models. Let's see, I've got so much project right here. So when we drew the Bohr models, these coming away from the nucleus, these were the energy levels. So this would be like 1 energy level, 2 energy levels, 3 energy levels. That's what I'm talking about here with periods equal to energy levels. And I'm going to go ahead and I'm just going to circle period 5 just to show this is a period. This is what I'm talking about. And if you noticed when I wrote the word period, I wrote it not up and down. I wrote it horizontal, just like my periods. If you want to draw an arrow like this, that's just fine too, because those are my periods going across. They determine the energy levels. And so in opposition to that, we have groups. Try to zoom in. I'm going to put this on this side just because later on I'm going to need a little more space. So I'm going to go ahead and just use group 16 here. I'm going to write right above this. So I'm going to put groups, and I'm going to write groups horizontally. So my groups, oh, no room for S. I'll just put group. So groups run up and down, or we call that vertical. I'm going to go ahead and circle group 16. Okay, so that's my group. And elements that are in the same group, they have similar properties. So when we say properties, think of like metals or nonmetals, and this is true for majority of these. There are some exceptions, and they also have similar reactivity. So think of the videos where the group 1 elements were mixed with water or combined with water, and we saw those explosions. So they all exploded. Everything in group 1 had some type of explosion, some big reaction. But as we went lower down in the group, those explosions got even greater. So that's what we mean by reactivity. All right, so we have labeled our periods, our groups. We labeled the reactivity. I'm going to also label this group 18. So group 18 is very, very special. These are kind of the snobs of the periodic table. They're kind of stuck up. And I'll tell you why here in a minute. So these are called the noble gases. So, I mean, right off the bat, you can think noble. You can think of like kings and queens, and they don't associate with peasants and the lesser than them. But these are all gases. So everything in, and I'm going to just draw an arrow down. So everything in this group 18, these are noble gases. And we talked about valence electrons. Valence electrons are those electrons. I'm going to steal this project again. Valence electrons are those electrons on the outermost energy level. Those are the electrons that we use in bonding or combining with other elements to make molecules and compounds and things like that. These noble gases, they don't react. They are stable. So I'm going to write over here, noble gases. I'm going to put stable. Oh, I ran out of room there. Let's see. I'll write stable. And they don't react. So basically, they don't want to bond. They don't want to get with any other elements. They are all good by themselves. So therefore, they are good. How we know this? Looking at our periodic table, I want you to circle all of the numbers in front of the A. So only the numbers in front of the A. If you look down here, these have B's. Do not circle them. Those are B's. We're only circling the number in front of the A. Okay, so we've got 2 and 1. So you should have a total of 1, 2, 3, 4, 5, 6, 7, 8. You should have 8 numbers circled, the ones that are in front of the letter A. These are valence electrons. So what I was just talking about, these are your valence electrons. And you guys feel free to kind of adjust this however you like to best fit your style. Valence electrons. I'm going to just label these. Valence, oh, that should be an R. Valence electrons. And I'm going to go ahead and draw a line over here. I've got my arrow there. These are valence electrons. So the number in front of the A, and this goes for all of them. All of them are valence electrons. That means that every single element in this group has that number of valence electrons that we just circled. So, for example, hydrogen, lithium, sodium, they all have one valence electron. If I was to draw, here's hydrogen. If I was to draw this as a Bohr model, I would have 1 proton, 0 neutrons in the middle in my nucleus. It has 1 valence electron. That means 1 electron on the outer energy level. But then also look at this. We did periods, and we said the periods were the energy levels. This only has 1 energy level. So that's exactly true and right. If I go to lithium, so here is Li, lithium. Lithium has an atomic number of 3. So that means I have 3 protons, and my mass is 7. 7 minus 3 is 4. That means I have 4 neutrons. So in my nucleus, I have 3 protons and 4 neutrons. In 8th grade science, remember the 8 atomic number equals the protons. It also equals the number of electrons. So lithium has 3. So remember, I can only have 2 electrons on that first energy level. I've got to make another energy level for my 3rd electron. Okay, so again, notice this outermost energy level only has 1 electron. So that, again, falls in line with what we were saying. The valence electrons, that's the number in front of the A. So the number on the outermost energy level is my valence electron. So here, again, I have 1. Hydrogen has 1. This is how they are on the periodic table. But then look, lithium is on the 2nd period. So that means it has 2 energy levels. And if I look, 1 level, 2 levels. Hey, that's true again. All right, so that's kind of what we are meaning when I'm writing these things. All right, let me think. Some other things I want to react. Oh, sorry, I'm jumping ahead. Other things I want to note. So on your periodic table, we've got this dark line. It looks like a staircase, or it looks like a zigzag. Oh, y'all, I'm so sorry. My elbow hit that. All right, so what I'm going to do, I'm going to darken it. And if I had a dark marker that I was using, I would do that. But I'm just going to darken it with my turquoise color just to make myself aware All right, so I'm just going to darken this so I can see it. So everything along this line is called a metalloid. So that means it has properties of both metals and nonmetals. Aluminum is my exception because aluminum is a metal. But we're going to use this to kind of gauge what elements are, or help us to figure out if they're metals, nonmetals, or metalloids. So everything to the left of my zigzag staircase, everything over here, these are all metals. So everything to the left is a metal. So I'm going to write this at the top of my paper here. So I'm going to put metals, and I'm going to say left of zigzag. And we're going to list some properties of these. So left of zigzag, metals are shiny. And I'm going to put shiny luster. Luster means the amount of shine. We're going to just put shiny luster. Metals are also ductile. They are malleable. They are great conductors. Good conductors. But they're poor insulators. So those are poor insulators. And then I'm going to put, let's see. So I'm going to underline metals, and then I'm going to put non-metals. So non-metals, these are on the right-hand side. So think of like gases or like sulfur. Sulfur is very brittle. So right of zigzag. And then we want to put on here my non-metals. So they're not shiny. They're kind of dull in color. They cannot be easily bent or shaped. So we are calling them brittle. So of course, like helium, oxygen, they're gases. So they aren't necessarily brittle, but the ones that are solids, they are brittle. All right, they are brittle. They are poor conductors, but they are also good insulators. Poor conductors, but good insulators. And then they're mostly gases. So if you look, they're mostly gases. So of course, everything in the noble gas group, those are all gases, obviously. Some of these you guys might know are gases. Sulfur, again, is not a gas, but that's okay. I'm going to put mostly gas. I hope you guys can see that fine. Yeah, that's okay. All right, so mostly gases. And then I'm going to put down here metalloids. And again, you might have to kind of adjust your paper as needed because I didn't quite tell you guys where exactly we're writing everything. But these are on the zigzag, except for aluminum. Aluminum's a metal. Think of like aluminum foil. All right, so metalloids are on the zigzag, and they have properties of both. Properties of both. Alrighty, so they have properties of both. And I think that is pretty good on that end. I mentioned here that noble gases, and you know what? This is kind of bothering me. I want to kind of separate that a little bit. Okay, so let's see, I'll zoom in a bit so you can see that. All right, so my noble gases, we said they are stable, they don't react. That's because they have 8 valence electrons. And if you guys remember, that outer level for electrons, the outermost energy level that we talked about in 8th grade science, we said the maximum number was 8. So if it has all the electrons that it can hold on that outer level, it does not need to go find other electrons or other atoms with electrons to give to it or share with it. It's good. It's set. It does not need any help with rent. Like, it's got everything it needs right then and there. So again, these noble gases have 8 valence electrons. It has a full outer energy level. I'm going to add, so these guys don't react, right? Or guys, gals, people, not people, my gases, they don't react. They're noble. They don't react. But back here, let me see how well this works. Okay, so back to my group 1. So again, these are the ones that we reacted with the water, and as we went down the group, the explosions got bigger and bigger. These are highly reactive. My group 2 are also pretty reactive. But my group 1 alkali metals are highly reactive. And that's because they only have one valence electron. So they have one valence electron. They only have one electron on that outer level. So here we go. Here's my hydrogen. Here's my lithium. There's only one. So they would need, like lithium, needs 7 more electrons on this outer level to make it happy, to make it stable. So it's so easy for it just to get rid of this one electron. So, hey, I need someone to come over here and bond with me. Like, take my electron away. That way I'll have, a stable outer level. And hydrogen, again, it's got one. We know hydrogen often pairs up with another hydrogen and oxygen. So it shares those electrons and it makes it stable and happy, as we want to say. So I'm going to add on here at the bottom that these group 1 and even group 2, these are highly reactive. These are my highly reactive elements. And of course, as I go to the right of my table, I'm going to put, should I do it? Should I do it? Should I make a huge long line with an arrow? I think I will. All right, so highly reactive, I'm just going to put an arrow this way and draw a nice long arrow here. And I'm going to put least reactive. And again, I apologize for my handwriting. And I'm going to put on this side, most reactive. All right. And yes, I know that there's other writing on here, and I could have found a periodic table that didn't have that, but the periodic table that I use is the same one that you guys will get for every test, every CFA, the STAR test. So I really want you guys to get used to using this one. All right. So most reactive over here, least reactive over here. Another thing that I just want to point out. So these elements in group 7A or 17, they have 7 valence electrons. Remember, the magic number is 8. So if our magic number is 8, how many electrons do they need on their outer level to be stable or happy? Hopefully you guys are all thinking they just need 1, right? You need 1 to go from 7 to 8. So this group, even though I know I put that this is your least reactive side, this group is also pretty reactive. I'm going to put just reactive right here because they only need 1. So they only need 1 valence electron to be stable. So they want to go out and find somebody who can give them that $1 to get into the basketball game. They just need 1. It's just 1. They need, that way they can be stable and happy and live their best atomic life. Let me see. Oh, you know what? One more thing I want to add on this periodic table. I'm going to put, let's see if I can zoom in. I've got a little bit of space up top. And y'all, trust me, we are cramming in as much information as we can on this reference chart, aka your periodic table. And I expect y'all to do this whenever you get this as well. All right, so I'm going to put this information on here about protons, neutrons, and electrons. So I'm going to put our friend proton up here first. All right, so protons. Protons are positive. They're inside. I'm just going to put inside because hopefully we know protons are in the nucleus. So they're inside the nucleus. I'm going to put, I'm going to put the word identity because hopefully by now you know and understand and you have tattooed it on your little neurons and brain cells that protons determine identity. Neutrons. Neutrons are neutral. I'm going to put a 0 with a line. So that means neutral. These are also inside the nucleus. And then I've got my buddy electrons. So I'm going to put electrons right here. And remember that electrons are negative and they are outside of that nucleus. I'm going to put a little arrow bracket thing here to remind me my protons and neutrons make up most of the mass. That was an exit ticket. I mentioned that earlier. Protons plus neutrons equals my mass. So that is most of my mass. Those electrons are so small, we really don't care about them when we're figuring out our mass number. All right, so that is that. This is something that you guys, again, should be doing every single time you get a periodic table. You're writing all over it. You're taking a brain dump on it. And this should help and guide you when you are taking your test. All righty, make sure you guys are asking questions if you need help with anything, and have a fabulous day.